This is Algebra 2, Chapter 6, Section 8, so 6-8. This would be natural logarithms, which comes directly after common logarithms. Then I'll start by talking about common logarithms. We notice that common logarithms were on our calculator in that form of log. If you take a look at this would be the common log. Now what we're referring to do today is natural log, and it's written as ln. And it's directly underneath the logarithm. Hopefully that focused in on that. These are the two that are located on your calculator. And so what is the natural log? Well, common log was based on the base of 10, which is what our number system is based on. Natural logs are based on a number called e. I will tell you that e is an irrational number like pi, or the square root of 2, and it is approximately equal to 2.71828. It's not equal to the square root of 2, I want you to understand. I'm just saying, like the square root of 2 in pi, it is irrational. And this is what it approximately is equal to. It does go on forever, it does not repeat. So that's what makes it irrational. You cannot use a fraction representation of it that is accurate. It can be approximation, but it can't be accurate. What is it used for? It's used in a few upper level formulas, such as continuous compound interest. Here's an example where the amount of interest you pay is equal to the principal times e to the rate times time. So whatever your percentage of rate is times the years, okay? It is one of two logs found on this calculator. Base 10 is also. It is written as a natural log of x. I'll give you an example here of how it is written. If the exponential form is e to the x equals 8, then this can be written as the natural log of 8 equals x. Notice that it isolates the variable, the exponent, and the answer is what we take the natural log of, ln of 8 equals 8. So it would normally be written like this if we didn't change it to ln, okay? So it would look like this. So if I'm going to do this one then, once again, we isolate the variable, and you can turn it around. I'm going to turn this one around, and I can say, well, 5 equals the natural log of x. Now, keep in mind that if I was to rewrite it, I would rewrite it like this in exponential form. But if this is an inequality sign, such as a less than, then this would be e to the 5th is less than the natural log of x. Okay? Because we're in a little bit, we're going to do a couple equations like that, and it gets a little bit confusing in what to do. So now let's start with the logarithmic form. Let's say that we have the log of x, and we have to say approximate equals 0.7741 because it's not an exact value. How would we write this? This is what it would look like if we wrote it with the logarithm. It would just be base e. So it's e to this power is approximately x. So we would take e to this power. It can be written the other way. It can be written as x equals usually e to the 0.7741. And that is written in exponential form. So, so if this is a less than or a greater than, then it's e to this power equals x. Okay. So if I want to do natural log of 10, that means it is. How would we write that in terms of? Oh, I didn't give you a value for that natural log of 10, did I? Equals x. I think we just let it be fixed. So then we would say 10 equals e to the x power, okay? Or e to the x equals 10, however you want to put it, okay? So basically we're doing all the logarithms. We're just simply saying that this one happens to be a base e, which is a special number. All right, we want to write this as a single log then. This is called condensing, where we have we can change this to the power, reverse the power. So this is the natural log of 10 to the 3rd power minus the natural log of 8. And then this would be the natural log of 10 to the 3rd over 8, which is 1,000 over 8, which is 125. Now, some people leave it like this, but some other people, and I would accept it like this, some people write it as this is 5 to the 3rd power, which is 125, and they bring it out. Oops, and this should be, I'm sorry, 3 times the natural log of 5. Okay, but either way, this way or this way, I would accept. Okay, so let's take a look at this one. This is a little longer one. It's 3 different expressions. You'll notice the second one has a 2 in front of it, which means that it has a power of 2. So before I do these two, I take it to 1/2 of the power of 2, which is 1/2 times 1/2, which is 1/4. And since I'm adding them, then I multiply them. That's what, when I put them into a single logarithm, and 40 times 1/4 is 10, so my final answer is a natural log of 10x. This is called condensing. Okay, it works just like logarithms, except for we're using the base e. Okay, so other things that we can do with logarithms is we can solve expressions just like we did with a common log. We can do something like this. If it says solve each equation, and then we want to round to the nearest 10,000, which would be 4 decimal places. 10,000. Okay, so let's say we had a problem like this. Number 5, we would have 3e to the 2x minus 5 equals -4. Now you have to be careful on these because when we take the natural log of both sides, we have to make sure that we have no negatives. Otherwise, it cannot be done. And I'll show you what I mean by this. To solve, we first of all want to solve for e. So we're going to move the 5 over and make it 1. Okay, and then I'm going to divide by 3. So I just eliminate everything but the e power, and what I get is this. Now you have to be careful here, because if this number is negative, okay, if this number is negative, it means that you're taking e to some power and getting a negative. That cannot be. You can't take a number to a power where the variable is here. It doesn't even matter if it's negative. You can't get a negative value here. So if this number is negative, you're done. It's no solution. Once we've isolated e by itself, e to a power, we take the natural log of both sides. Now it's very important that you take the natural log of both sides. If it wasn't for e, you could take the common log of both sides, which is normally what we did in the last section. But in this case, since it's a base of e, we're going to take the natural log of both sides. And I use the power rule. So we have 2x times the natural log of e equals the natural log of 1/3. Okay? Now you will see that the natural log of e is like any other logarithm. If I have the logarithm of 5, base 5, my answer is 1, because 5 to the first power is 5. Same way with here. E to what power is e? It's 1. So what I have is 2x times 1. This value of this is 1. So let me say that again. Anytime you have the natural log of e, the value is 1, equals the natural log of 1/3. Okay? I divide by 2, and I get x equals the natural log of 1/3 divided by 2. Now it's very important how you plug this into your calculator. Your calculator will put a, when you push natural log, it'll automatically put a parentheses there. So we want to take 1 divided by 3, parentheses in, divided by 2. Okay? And when you do that, you should get a value of, you should get this value. Okay, so it would be a negative, if I'm going to the nearest 10,000, put this down for a second, I would get a negative 0.5493. Okay, it's negative. Okay, and that's how we solve an equation. All right, now inequalities can be solved the same way. Okay, but do make sure that this value is negative when we're talking about equality. Or it's not negative when we're talking about equality. Otherwise, we have no solution. Okay, so let's take a look at a couple other problems. And let's take this one. This would be example 6. Let's say that we have the 3 times the log of 4x 4. Okay. So I'm going to isolate the natural log. So I'm going to divide both sides by 3. And what I get is the natural log of 4x equals 8. Okay. So this is e to that power. This is base e to that power. So I can say 4x equals e to the 8th. Is that correct? Okay. 4x equals e to the 8th. Now to solve for x, I'm just going to divide both sides by 4. And I get x is equal to e to the 8th divided by 4. Now, to do that on your calculator, I'm going to clear this one. To do that on your calculator, hopefully you can see it. I'm just going to take e, which is second natural log, and you can see it's e to the x, to the 8th power, and I finish the parentheses, and then I divide by 4, and I get 745.2349. Okay, now, or 2394. So I'm going to write all that out. X is equal to 745.23905. Okay? Now let's take an inequality, which is a little different look. Okay? So I'm going to go the natural log of x minus 8 to the 4th power is less than 4. Now you've already have the natural log solved for, just like you did here. You're in this situation. So x minus 8 to the 4th power is less than e to the 4th power. That's what we did here. This is the exponent, okay? Since we have that, we can take the 4th root of both sides, which